In this session, we will learn about another algorithmic design strategy called divide and conquer. The strategy behind divide and conquer is, as the name implies, the first one is divide. If the problem is small, then we can solve it directly. Otherwise, we need to divide the problem into smaller subsets of the same problem. The second strategy is conquer. Once the problem has been divided into smaller problems, we need to solve them directly. That is conquering. And finally, we need to take solutions of these subproblem, merge them together to get the solution of the original problem. So that is combining. So the main strategy of divide and conquer is divide, conquer, combine. So this picture will give you a clear explanation about the strategy. So the given problem is divided into subproblem. That may again divide into sub-problems. That may again divide into still smaller problems. Then once we have reached a smaller problem so that it can't be further divided, in that case we will solve the problem. We will get solutions to the subproblems, and this phase is called as conquer. So once we get solutions to these small problems, we will combine this solution. For this problem, we will get solution here. For this problem, we will get solution here. For this one, here. For this one, here. These solutions are again merged together, combined, so that the solution of the subproblem comes here. The solution of this subproblem comes here. And these two are in turn combined to get the solution of the major problem. So this is how divide and conquer works. So the basic algorithm behind divide and conquer is, as already mentioned, if the problem is very small, then you do it directly. Else, you divide the problem into so many subproblems. Then apply divide and conquer to these subproblems, and finally combine the solutions of these subproblems, which will be returned back. The recurrence relation for these divide and conquer strategy can be written like this. If it is small, n is small, directly you can write g of n. Otherwise, you find out the solutions for all these subproblems and combine all these solutions. So that combining process will have some computation time that is given as f of n. So in general, it can be stated as, if n is 1, then t of 1. If n is greater than 1, then I have to divide into subproblems. So this a denotes the number of subproblems, and this n divided by b denotes the size of the subproblem, plus fn denotes the number of operations that I am doing. The main advantages of using divide and conquer are, it is very easy to implement and understand. It reduces the time complexity of the algorithm by breaking down the problem into smaller subproblems. It can be used to solve wide range of problems like sorting, searching, and optimization. It can be used even in parallel computing to improve the performance. The disadvantages are, it can be difficult to determine the base case or the stopping condition for the recursive calls. It may not be most efficient algorithm for all the problems, and it may require more memory than other algorithms because it involves storing so many intermediate results. The applications of divide and conquer strategy includes merge sort, quicksort, binary search, finding minimal and maximal element in an array, finding sum of maximum subarray, Strasson's matrix multiplication. In all these areas we will be applying divide and conquer strategy. Thank you.